So this is another video about the current electricity problems. Okay, now we have in this problem we have battery, a cell that has internal resistance, and another thing is that the resistance, internal resistance R is must be equal to the external resistance capital R. So internal resistance and the external resistance both are equal in magnitude. Okay, and okay, now when switch is open, so we have to identify which of the following is not equal to the EMF. Which of the following is not equal to the EMF? So number one option, the reading on the voltmeter when the switch is open. So when switch is open, so question number one, when switch S is open, so we have to justify, we have to check whether this the resistance reading on the voltmeter is equal to EMF or not. Okay, so so when the switch is open, no current flows through the switch, so that the potential so the voltmeter reads only the EMF of the cell. So the voltmeter reads only the EMF, so that is equal to the EMF. So not equal, so this is the wrong option, so A is incorrect. Okay, now B, the chemical energy changes to the electric energy when the unit charge passes through the cell. So this is also the EMF, because this is definition of EMF, because we know that the so the definition of EMF is the change of chemical energy into electric energy when unit current passes, unit charge passes through the cell. So this is the definition of EMF, so this is also equal to the EMF, so we have to justify it is not equal to EMF, so this option is also wrong. So this is the proper definition of EMF. Definition of EMF: energy per unit charge, because we know that EMF is energy per unit charge. Okay, now C option, so when switch is closed, C option, when switch S is closed, so C option, so B is also incorrect. C option, when switch S is closed, when switch S is closed, so when switch is closed, so reading is twice the voltmeter. So when switch is closed, so when the switch is closed, so that the current passes through this circuit, the current I passes through this circuit, and that also passes through external resistance. Okay, that is equal to internal resistance. So capital R and small r equal. So the Vt is equal to, the formula is Vt is equal to E minus IR. So E is equal to Vt plus IR. So Vt plus IR, you know that the R is equal to, small r is equal to capital R, so this is also equal to capital R. Vt plus IR is also Vt terminal, so 2 times of Vt. So the EMF is equal to 2 times of the Vt. EMF is equal to 2 times of the Vt. So the when the so double of the so EMF is equal to 2 times of the potential difference Vt. So the twice the reading of the voltmeter when the switch is closed. So the twice of the reading of voltmeter to Vt, that must be equal to EMF. So this is C is also equal to the EMF. So this option is wrong. This actually, because we know so we have to check the which option has not equal to the EMF. Okay, the electrical energy produced when the unit current passes through the cell. So this one is, I think so, this is the correct option, because the you know that this is not this definition is not the EMF definition of the EMF, because EMF is equal to work done or energy per unit charge, and but you know that the EMF is when total EMF is when no current passes through the circuit, when no current pass through circuit, so that the total reading will be EMF. But when the current I passes through the circuit, so the potential drop, the electrical energy produced through the cell is actually less than the EMF. So terminal potential difference is less than the EMF, because when current I passes through circuit, so it means the current I then the current I passes through the, so Vt is less than the EMF. So Vt does not equal to EMF. So this option is the correct option. Which one is not equal to EMF? So D option is the correct one. Okay, thank you. So D option is the correct one.